at that. Wow. Thank you for bearing with everybody in the conference and for coming to the best talk. You've had to sit through some amazing ones, but this will blow you away. It won't. It won't. My slides are online, okay? So you don't have to worry about taking notes or anything like that. If you want to ask me questions, do not mail me. I'm the worst person in the world at email. I have over like 10,000 emails in my inbox that I'm just never going to get back to. Tweet me. I'm addicted to Twitter. Okay. So this talk is called Continuous Delivery, the Missing Parts. Quick hands up, who thinks they do continuous delivery? Oh, a couple of ballsy people, wow. Okay, so at the end, we're going to take exactly the same poll and see if those people still believe they're doing it, okay? So, my name's Paul Stack. I'm an infrastructure engineer for a semantic search-based company in London. That basically means we're doing cool stuff with neural networks in order to make images face and work within each other in the semantic space. It's really cool. I'm a reformed ASP.NET and C# developer. I mean that with no disrespect whatsoever. It was Windows that I fell out of love with, just because it became so difficult to automate that I didn't want to work in a Windows environment anymore. I'm a DevOps extremist. I love DevOps. It's changed completely how I think of everything that I do on a day-to-day basis. And lastly, I'm a conference junkie. This is my 13th conference of the year, and I have 3 more to go before Christmas, so quite a few. Background to this talk. I have seen so many people tell me that they're now doing continuous delivery. Okay. Now they say, oh yeah, we have just implemented continuous delivery in our environment. It's like, okay, what does that mean? And we get some common misconceptions, which we'll talk about. But what I wanted to do is I wanted to take away a lot of those myths. Okay. Continuous delivery is not something that's very easy to do checkbox exercise for and just say that you're doing it. Okay. It's an ongoing job that changes as your system changes. It's very important to remember that. And there's a lot of different components of continuous delivery. So for background, for those who have not heard the definition of continuous delivery, it's a set of practices and principles aimed at building, testing, and releasing software. Okay, most important thing on that slide is the release of the software. Because as developers, we don't like releasing software. We're afraid of releasing software. And that has come from too much risk associated with it. Hands up, who has ever introduced a bug into production? It is easy. Because we do it every day. And what happens when we release a major bug into production? We have more red tape put around our process in order to make that bug not happen again. And that makes releasing more difficult. And when release is difficult, we don't do it. We don't practice it. It's not something that's part of our core job. Hands up here who releases software every day. A couple. Hands up who releases software more than once a day. When the first release went wrong. It's true. It's true. Hands up who only releases once a week. Hands up who releases more than once a month. A couple of us. And I understand that there are types of systems that we work in that mean that we can't release more than once a month if it's an embedded system or mainframes or so on and so forth. But still, there are processes put in place in order to make this more difficult. So, these are all well documented. There are 8 principles of continuous delivery. We're not going to go through them because they're boring. But we have 4 practices of continuous delivery. These are the 4 key practices, okay, that work across the entire piece of the puzzle. You build your binaries once. Please. Please, 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 please. Please do not rebuild your binaries between a QA environment or a testing environment and production. Okay? Build them once. Fix any bugs, rebuild them, and start the entire pipeline again. Okay? Number 2, use precisely the same mechanism to deploy to every environment. That does not mean GitHub push goes to QA. And if it does, hang your head in shame and give yourself a little slap. Because if that's not how you deploy to production, then you shouldn't do it to QA. If that is how you do it to production, give yourself a bigger slap. Okay? Number 3, smoke test your deployment. How do you know if your deployment has been successful if you don't test it. Who tests their deployments? Less than 50%. By the way, the rest of you are not doing it wrong. It's a common thing. This is what we do. Okay? And number 4, if anything fails, stop the line. This is from the Kanban principle, the lean principle. You don't let changes and bad effects go upstream and downstream. Okay? Fix them. Don't let somebody else deal with your crap. It's very important. Anyone read the book? A couple of people. Continuous Delivery. Written. You're still reading. It's a very difficult book to read. It's a lot. There's a huge amount of information. I think it took me about 6 months in chunks. Okay? But I was reading large chunks of it at a time when I was bored at my last company. And this book was first released in 2010. Okay? Am I then saying that continuous delivery is only 5 years old? No. Continuous delivery actually came about at the time of the Agile Manifesto. 1 second, my slides are busted. Let's see if that's any better. Excellent. Yeah. So in February 2001, okay, I was only 9. I'm young. In 2001, lots of amazing software developers at that time came together, okay, who have grown into some of the most influential figures in IT, okay. Now we're talking people like Martin Fowler, Bob Martin, Kent Beck, Ron Jeffries, Jeff Sutherland. These are people who are the forefathers of modern Agile, okay, who shaped the way we delivered systems. And they said, our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Okay. So this is not a new thing. This is something that has actually been around for a long time. Kent Beck he was releasing multiple times a day to production in 2001. And there are some common misconceptions that have sprung up. There really are. They're in no rank of order, but as we go through, they get worse. Number 1, continuous delivery is only something that startups can achieve. I worked in a very, very monolithic organization for 4 years, and we changed our system from a very large ASP.NET website when I first started it. Do you remember those websites? They weren't even a web app. You couldn't even compile most of it. Okay? And then we actually changed to much more smaller deployable units, not microservices. Not microservices, okay? But we were doing that multiple times a day. We got there. We were an old company where I would definitely have classed as an enterprise-style company. Number 2, continuous delivery only works for Node.js or Ruby or Go or whatever the language of the day is. Rubbish. Doesn't matter. You put the correct practices in place, and it can be for any language. Any language. As I said, I did it for .NET. And people could always go, oh, .NET's very difficult to deliver. Windows, it's not. You just have to put the time and effort into delivering it. 3, this is one of my favorites. I'm sorry to all the consultants in the room, but you cannot hire a consultant to implement continuous delivery. You can hire a consultant who will help point out areas in which you need to get better at, but at the end of a fixed length contract, in my opinion, they cannot have a checkbox exercise that says we're doing this, 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 we're now continuously delivering. Because they don't know the ecosystem. They don't know the value of the company. They may not understand what the users want, okay? That's just probably automated build and release, but they have to go and do all the rest. Continuous delivery is not right-click and deploy in your IDE. I know somebody at Microsoft who has done this to a production system. They have actually gone right-click and publish. Please don't. And number 5, continuous delivery is as simple as hooking GitHub to our Azure or Heroku accounts. It's not that either. So we got rid of all the misconceptions. And if you're doing any of those, let's hopefully learn something and let's try and be a little bit better at what we do. My favorite quote came from 2011 from a guy called Chris Reed, who used to be a thought worker and now works at a place in America called DFW. Okay. And Chris said, until your pretty code is in production, making money or doing whatever it does, you've just wasted your time. This goes back to the continual release of valuable software. I'm all for the craftsmanship movement. I'm all for DDD movement, okay? Because they will allow us to build better, more modular systems. But at the end of the day, if it takes us 6 months to put a system like that in place, and we can put a small test in place earlier, like 2 months, let's take the 2-month route first and see if it's worth it. See if you want to spend the time in order to make that big sacrifice and big change. Haven't I just contradicted myself? Haven't I told you that it's not about hooking GitHub to Azure, but yet it's about releasing your software fast? Wouldn't they go hand in hand? No. How we get the software to production and how we keep it there are two very different things. Okay. Step 4 or step 5 of software delivery is probably the release. Step 99 is the deprecation of the software in production. Has anyone ever deprecated software in production? Like 3 people in here, okay? So all that software that you've been creating is still in the world right now. And it still has to be managed, and it probably still has to be scaled at certain points of the year. And things need to change and flow with the invention of the cloud and the invention of Docker and all of these different things. Okay. You're never just going to leave it there festering. Otherwise, you're probably going to be still running Windows NT in production. Does anyone please tell me no one's doing that? Please. I don't want to know. So I started to understand that how a company was structured through the word DevOps, how the company was structured meant that how we could understand the complexities of delivering software. Now, obviously, Conway's Law exists, and there's been talks about that here, and I'm not referring to that right now. What I'm referring to is the separation of people and the non-communication between lots of people. Okay, so I Googled a traditional technology company, and I actually got something that looked like that. Okay, and I'm sure a lot of people in here have worked in companies that have got that horrid structure, but these people probably don't know each other. These people probably don't know what the other person in the company does. So therefore, why is it fair for them not to understand what they're trying to deliver? Aren't we supposed to be one team? We are. By creating all those layers and those silos and all those departments, we're effectively stopping ourselves from being as fast and agile as we can. We really are. So we can ask ourselves, how long would it take your organization to deploy a change that involved a single line of code, and can you do it on a reliable, repeatable basis? Anybody want to give me a measurement? Half an hour. Excellent.
3 months.
3 months.
Yeah.
Okay. No, not at all. Not at all. If that's the process in your company, then I'm not saying that, as I said, this is not a case of you're doing it wrong. Okay, we're not doing it wrong. Okay, any advances on 3 months? 3 days. Okay, so usually, this is the first time that this has not happened. Usually I'm told one of 2 things. Well, for development purposes, it takes us X amount of time. But if it's a bug fix, it takes us Y amount of time. Okay? Because we can deliver a bug fix to production faster than we can deliver normal code to production. Does anybody work in an environment like that? It's true. So let me ask you the question. Why does normal development change from bug development, from bug fixing? Still code. Still got the same steps to go through. Why are those steps not the same? Yeah, agreed. So why can't we deliver normal code that fast? we take more risk. Ooh, here we go. Right. Everything's a risk, I agree with you there. But it's an insurance premium, right? There's a whole thing around this. It's called cycle time. Okay? Cycle time is defined as the time from the beginning to the end of your process. Okay? From that minute you start writing code until that minute it goes to production. And in my last company, I measured the cycle time. Okay? And we can see that an issue was reported, and then we waited for a number of days, and then there was a prioritization meeting, and we waited for some more days, and a developer fixed things, and we waited for some more days, and so on and so forth. Okay? 19.5 days of waiting. 19.5 days. That's almost a month of a person's time waiting for that software to be going through the system. And a new CTO joined the company, and he asked me, he says, Stacko, why are we delivering software so slowly? Why can we only deliver once a month? And we sat down and we drew it, and he was like, but look, you can eliminate all of those 4-day portions. And wouldn't that infinitely speed it up? Yeah. Until we drew it, until we measured it, we had no idea. Draw it. Go back to your company on Monday and draw it. Okay, you can go and you can find articles about cycle time and value stream maps on Google. Okay, go and draw your flow. Because if you draw your flow, you'll understand areas in which it can get better. The value stream for the operations team was even worse. It used to take 8 weeks for a VM to be delivered. Okay, I got that down to just before leaving the company of 6 minutes for a Windows server. 8 weeks to 6 minutes. And I was really pleased with myself. And I thought, oh, I'll go and speak to the CTO and say to him, hey, it's 6 minutes now for a Windows server. He goes, tell me when it's 3. Because we should never give up our improvement. We should always, I don't even know if you can boot a Windows server in 3 minutes. Probably with the new Nano stuff you can. But he served a point that we should always be striving to be better and always be striving to make it faster. It's not all doom and gloom. We have some amazing people in the IT industry who are trying to bridge the gap between all of these departments. And this is where DevOps came from. Anyone heard the term DevOps? More than quite a few of you. Okay. So in 2009, in Santa Clara, in California, we had a talk called 10 deploys per day, Dev and Ops Cooperation at Flickr. Okay. And you had 2 people giving the talk. This man on the left is John Allspaw. This man on the right is Paul Hammond. Okay, John Allspaw now works at Etsy. Paul Hammond, as I knew until lately, I don't know if he's still there. I don't actually know, to be honest with you. Works at Slack HQ. And what they talked about was John was from the ops side, and Paul was from the engineering side, and they talked about how they collaborated to release software 10 plus times a day. Now, in 2009, I was still hacking the hell out of web forms. I can't imagine being able to put myself in a situation of being able to deliver 10 plus times a day back then. So this was groundbreaking for a lot of people. And discussions came around on Twitter about why don't we bring this style of conference to Europe. And in the 30th and 31st of October 2009, any Belgians here? None? Good. I've been told there are 3 things that Ghent is good for. Beer, chocolate, and frites, chips. Okay, so, there's questions about why was it in Ghent? I'm just joking. And they had developers and operations or system admins there, and it was for 2 days, and it became known as DevOps Days. Wow, does anybody see where this is going? And what happened is the event was over, and they continued hashtagging it DevOps Days. And because space on Twitter is a premium, they thought, well, why don't we, the days are over, let's cut the days out of it, and let's just use the term DevOps. This wasn't a term that was invented by 20 executives sitting around a board meeting table. This was an actual thing created from a conference of collaboration. And what it did is it started introducing a whole new set of tools that do many, many, many different things. Oh. Okay, you have Jenkins, Vagrant, Logstash, Sensu, Graphite, Chef, Puppet, Terraform, Grafana, Many more. Many more. There's a new tool comes out every single day for DevOps because it seems to be where startup and VC money gets thrown into. Okay. Google DevOps Tools. You'll have pages and pages and pages of them. You really will. And what it was decided to do is we used to have what's called the wall of confusion. Devs on one side, operations on the other side. Devs want change, ops want stability. I worked in a company that used to pay operations people for uptime of the system. Okay, so if the ops people were being paid for uptime of systems and developers wanted to be changing things, the ops guys would go, nope, ain't happening, because that would directly affect their pockets. And I can see some people nodding. This happens, it still happens now. And if you actually want the definition of what dev and ops are, DevOps Borat says it best. If you're praised for website success, you're a dev. If you're blamed when the website goes down, you're ops. Those poor guys. We have a life. We don't have a life. And what the general way of software is, developers create a package and they throw that package over a wall and operations people are expected to deploy it. Let me ask somebody a question. I have a USB stick right here. Would you mind putting this in your laptop for me? So why should I deploy your crap to production if I have no idea what it is? Okay, it's about collaboration and understanding what you're trying to release, what you're trying to build. And you don't end up in a situation like this. It worked fine in a dev environment. It's an ops problem now. Thank you, Docker. Because if it works on a dev machine, we ship the dev machine. But the biggest understanding is DevOps is not about learning each other's job. It's about understanding the money is actually made when your software is running in production. So how does DevOps help? DevOps has 3 ways. Okay? We're going to gloss over these really fast. Communication from left to right, from dev to ops. Okay? And that helps us understand work. There are 4 types of work. Business projects, so like search improvements, UI improvements. Internal projects, architecture changes, moving to microservices. Changes themselves, so changes happen every day. Schema deployments, actual deployments of the applications, anything like that. That's classed as a change. And then the last one, which is the killer, the unplanned work. Okay? Bug fixes, downtime, investigations, things that we don't actually plan for on a day-to-day basis that suck up all of our time. So the first way is about understanding the flow of information from dev to ops. What does anybody think the second way is? Understanding the flow of information from ops back to dev. Wouldn't it be really good if an ops person could turn around and say to you, hey, that application that you deployed yesterday rose our CPU by 18%? Because then you could start to look at it and go, well, maybe I've written some unperforming code. Maybe I have 5 database calls when I only need 1. Maybe my ORM does a select n+1. Because we all have little bugs that just make their way into the system. But we don't know about it until we get that feedback. Patrick Lightbody from BrowserMob, he was the CEO, said, we found that when we woke developers at 2 a.m., defects got fixed faster. Funny that, isn't it? Does anybody in here get paged? You lucky, only a couple of people. Wow. I get paged for everything. And it's not nice. Because usually my other half is even more annoyed than I am. Because the pager goes when it's in our room and it wakes her up as well. And I will guarantee you that the same bug will not wake me up 2 nights in a row. Because otherwise the feature's got to be turned off. It's not ready for production. And when you understand the flow of information from left to right and right back to left, you can then start to be really good at what you do. You can start to create a culture of continual experimentation and learning. Anyone do multivariant testing? No? Anybody know what multivariant testing is? Okay, so let me put it this way, okay? If I have a website, and I have a very small percentage of people that I want to test a new feature on that website with, that would be a multivariant test, okay? like A/B testing, okay? Facebook are the most famous company for doing this. Facebook released their features in production to 17% of the female population of New Zealand. That is not a made-up statistic. They actually told us that when they came to my last company and actually gave us a talk about this. Because that's a decent enough representation of the population of the first people of the world in a time zone that comes around. And they will know if a bug happens before it hits one of the main metropolitan cities in the world. Okay? It's very clever. And Etsy are another very famous company that do it. Etsy are like an eBay for craft, vintage pieces of stuff. And at any one point, Etsy are running hundreds of multivariant tests. Okay, that could be as simple as moving a button from left to right on the page, or taking out the rounded corners and putting the square corners back, or changing the button from red to green. Okay, these are all little tests that you can do. But if you have a really good understanding of the flow of information, and a really good understanding of the actual systems themselves through the pieces that we'll talk about in a minute, then you can start to do that very easily. There's some good books on this, okay? This one on the left is called The Goal. This was written in the 80s. This is probably my most favorite IT tech book, okay? It's a story about a manufacturing plant and about how they effectively understand the flow of the system through the manufacturing plant, okay? It's written in the 80s, and it's still as valuable today as it was back then. It really is. And then the book on the right, it was a rewrite written in 2012, I believe. Maybe 2012, maybe 2011, I can't remember. I'm really sorry. And it's the Phoenix Project. It's the same story told about an IT organization. If you want to understand how your company works and understand the flows of information amongst your company, have a read of those books. They're invaluable. And what it teaches is that we can adopt DevOps through 4 things. Okay? Culture, automation, measurement, and sharing. This is as simple as it's down to. Culture, people and process first. If you don't have the people in place for your organization, and you don't have the people who are actually excited enough to work in this new way of doing things, it's a waste of time, folks. I said you can't bring in a consultant to do continuous delivery. Probably because of this. Because if you've had to hire a consultant in, it means that the rest of your organization are not embracing it enough. Automation. Once you have the people, once you have your culture, you can start to automate whatever you want. You take tiny little pieces of automation and make it better and better and better until you get a really good fabric of your system. Okay? Measurement. If you can't measure it, you can't improve. If you don't know how many bugs are in production, if you don't know how long response times are taken, if you don't know the average journey time of a user on your system, you can't make your system better. Measure everything. Lastly, share it. We are all part of the same organization. Not us in here, obviously. Because that would actually be quite good, because that means you would all be decent devs. But if you're inside an organization, share the problems. Don't be that person that's afraid to put your hand up and go, I'm sorry, guys, I introduced a bug. Okay, we all do it. Everybody put their hand up at the start. Take it as a way of being better and learning and getting better at it. Metrics and automation are key. Okay, I use a system right now called Grafana. Grafana is a free tool, and it allows me to start drawing pretty graphs that look like this. Now, you might not see them because it's the black screen, and I'm using a really dull video. But effectively, we can see the system load as messages pass through our system, and every one of these red lines right here is when a deployment has happened. Okay? So I'm measuring the change of system load when a deployment has happened. And we're messaging message queue length. And look, it was trailing and trailing and trailing, and we found a bug, and then we actually released a fix for that bug, which took it down for a little bit because it was somebody's quick hack, and they went, oh, I've actually realized that there's a problem in that piece of code. Let's try and put something around that. And look, the message rate dropped. And then we go, okay, let's productionize that fix. So we put in another bug fix right here, which allowed it to drop again. And back within the space of a day, our message rate was back to 0. Measure it. It's all there. This is not new. There are many people out there doing this. I know there are people doing it. There are people in this room doing it. Make it a wide practice. Make it shareable amongst everyone else in your organization. Does anybody collect logs in their system? Centralized logging? Really simple. This is a UI called Kibana. Okay, Kibana is a UI across the front of Elasticsearch. Okay, I've given a talk before about how to scale Elasticsearch and login infrastructures to take 1 billion messages a day. I'm taking them a much smaller scale right now because I'm a much smaller company than I was before, but everything is logged. New sessions, status codes, JSON parse failures, everything in our system is logged. ELB health checks, and it's just a really simple blob of JSON and the path and the host and the type and the timestamp, and we can just throw it into Elasticsearch, and Elasticsearch will allow us to measure it and understand rates of change. Make sense? The actual Grafana itself is a UI, okay? And the newest version of Grafana talks to many different systems. And my monitoring system in the background is called Prometheus. Prometheus is a newer monitoring system. It's a pull-based metrics rather than push-based. Usually you would use something like collect D and you would push metrics into Graphite. And then Graphite would churn them up and you would understand them. Prometheus actually crawls data instead. It goes off to all the boxes that you specify. Like they're all here. And all the ports and all the job names. And it will grab metrics. Okay, and you can start to actually change things and graph things and so on and so forth. Node boot time, and we can see all the node boot times across all the boxes and all the jobs. Grafana just makes this easier to read and easier to understand. Okay. The key is put a metric system in place. Trademark. And if you don't want to, I'll come and do it for you. Right, I've lost my, there we go, we're back. And where that leads us to is the technical side of the business post-DevOps. Okay, so I've been like, what, 20 minutes so far? Does anybody, oh, I've been 30 minutes, right? So I've got like 25 minutes. We're gonna do some cool demos, I promise. Okay, and when you get to the technical side post-DevOps, it shows there are no boundaries between your systems. Okay, this was actually a graphic presented by John Turner of paddypower.com, okay, in London in 2014. And he captures the essence perfectly by saying, anybody in our technical organization can work on anything here. Because they're all as important as each other. And because they're all as important as each other, they all have to be part of the story for their deployment and for their automation. Okay, there's a lot of parts to CD. And this leads us to the missing parts, which unfortunately are the ops parts. Any ops people in here? Okay, so ops is a bit of a weird art right now, okay? I classed myself as an infrastructure engineer, and somebody asked me, what does that mean? It took me about 2 weeks to understand what it meant, okay? Firstly, I build systems to make the lives of my development team much easier. Okay, so I put the metric systems in place. I put the logging systems in place. I try and help change the culture to understand why those are needed. Okay, but most importantly, I'm the one that's responsible for the health of the entire system. Because there has to be somebody who has to take advantage of the entire system. There has to be somebody who knows that when this application over here starts to get really hot and takes more requests a second, that it could be because of a downstream effect. Okay. It's not that I run the architecture. I just need to know that the metrics are in place between the pieces of the puzzle. The orchestration layer. And there's ways of doing this, okay? Firstly, configuration management. Anyone use a config management tool? Anyone use any of those that are not listed? For example, Microsoft SVVM. Okay, so you've got the main ones here. You've got Ansible, SaltStack, Chef, Puppet Labs, and CF Engine. Okay. They all do very, very, very similar things. And they're very good at what they do. Very good at what they do. You tell a system what level of configuration it needs to be. These tools will bring it to that system. Okay. That'll be patches. That'll be IS configurations. There are many, 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 many open modules for these for Windows support. So this is not just a Linux thing. There's a different approach of people, including myself, who think that immutable infrastructure is much better. I do not redeploy any applications to boxes. I redeploy entire boxes every time. Virtualization is amazing because it's cheap. And I work in the cloud. And it means that I can probably spin up a box in AWS for a very tiny application that costs me cents per minute. So why would I go and try and make the risk of changing something that I know already works? Deploy something new, smoke test that that deployment works, and then swap that into the load balancer instead. It's a proven way of doing it. And where this came from, the earliest, should I say, that I heard of this was in 2013 by someone called Chad Fowler. Okay, Chad Fowler is very, very, very well known in the Ruby world. And he now works for Six Wunderkindle that make Wunderlist. Okay, they were bought by Microsoft this year. Very successful company. And he actually wrote the article back then saying, trash your servers and burn your code, immutable infrastructure and disposable components. Anyone ever heard the term, treat your infrastructure as cattle, not pets? Because we don't want to kill pets. It's not good to kill cattle either, because it's inhumane. But unfortunately, that's the way life is. Cattle are bred for meat, and meat isn't blah, blah, blah. And some people, you F-sharp people and your Haskell people, have taken offense, and they were like, well, it's not immutable infrastructure, because there are things written to disk. So last year, or earlier this year, Mark Burgess, who is actually the creator of CF Engine, said, why don't we change it to disposable infrastructure? Doesn't that make more sense? And it does, because infrastructure is made, and you know that infrastructure can be disposed of. We went through logging. You can build logging frameworks and logging clusters that do all different things. And what that enables you to do is things like this. This is another view of Kibana. This was from my previous company. I probably shouldn't have stolen the screenshot still, but it just proves that it's awesome. Okay? We can see that a single team, okay, their applications, their cluster of applications takes 22.4 million requests a day. And we can see that that team had 70 non-200 responses out of those 22.4 million, because we're measuring everything. That's a very low percentage. They were told off for that, because it rose quite. And you can start to see total requests, and requests spiked, and we could then start to see when requests spiked, cache misses happened. And you could see when cache misses happened, average response times at the end started peaking a little bit, because you're layering the graphs on top of each other. It's really useful what you can do with this. And you can go to the metric stuff, which I showed you before, and then you can layer the metrics on top. You can see server requests, you can see CPU, client loads, all of these things. Monitoring. Does anybody in here know what monitoring tool their company uses? A couple of you. Does anybody in here actually write code for their monitoring system? I love you both. Honestly, you're amazing. At my last company, we started off by this segregation of ops and dev. And everyone asked me, how did you get rid of it? And we got rid of it by saying to the operations guys, check the monitoring tests into source control. And then let the developers send pull requests when they needed a new monitor added. And you could write code that looks like this, because we used Puppet to deploy our monitors, our Nagios monitors back then. Okay? And for what the developers knew the application was doing, what ports it was on, what services needed to be running, It meant that they could actually relay through documentation, because it was a documented test right now, what types of systems that they needed. Okay. And then you would find an operations guy coming back and saying, hey, that's the port that's running on, we have a conflict because we know that there's something else running in the system. Because you were opening up, that pull request became a communication method between the people. And we could start to write some very interesting stuff in Elasticsearch, and there's loads of checks in my Nagios repository. And then I moved on, because I don't use Puppet anymore, because Puppet wasn't cool for me then when I left that company. So I moved to Ansible, and you could start to write your checks in YAML in Ansible, just because YAML seems to be the new cool, and it's very easy to understand. And you could do exactly the same thing. You could check that services were running, you could check percentages, you could check RAM, you could check the different intervals. And then I use Sensu now for the actual monitoring tool, and I'll show you that in 1 second. And it's a pull-based system. Let's go and destroy some infrastructure. Because why not? Because my boss is currently, oh, he's still working, crap. Let's see. What do we do? Right. Let's go to AWS. I'm actually going to destroy I'm probably going to get alerted while I'm here, but that'll be funny. Oh. So my monitoring tool, come on. Every time a new box comes up, it has a script as part of its base image in Amazon that checks itself into the monitoring tool. Okay? And when a box terminates itself, or is destroyed, or the auto-scaling group destroys it, it removes itself automatically. Okay? And we're going to watch some boxes be destroyed. Let's choose something that I know is not going to cause any problems for me right now. Let's do a log stash box. Okay? So let's go. Let's go to Logstash. 66155. Right, watch this box right here. Okay, I'll come back to it in a second, I promise. Terminate. Please come back. Please come back. So I have an autoscale group around this. Autoscale groups are the best, because if you tell it a number of boxes to keep running in your system, autoscale groups will then add the appropriate boxes to make it come back. Oh, it's disappeared. I now only have one Logstash box. That was fast. Okay, so we're going to get a termination event, which is happening right here. And let's go to Slack. And let's hope that nobody has noticed. And we have a notifications channel, like everybody does for this type of stuff, so that they can understand what's going on if ever it signs in. I have 9 Slack channels that are organizations I'm a member of right now. But effectively, every time a termination event or a launch event happens, we actually post it in here, because we want to share all that information. I've been woken a few times where I get pages for a box that's just disappeared, and I wake up in the morning and it's gone. I'm like, where did the box go? You can go to the notifications channel and you can find the AMI ID, the instance ID. You can see that it's been destroyed by the autoscaling group or whatever. Okay. I don't know why that's not signing in. Just thinking about it. We'll come back to that in a second. And if I refresh, it's actually thinking about creating a new one, because one is currently terminated. It takes like 30 seconds or something for a Logstash box, because it doesn't have to be high availability for Logstash. It's not in a load balancer. I have a queue of messages that's building up, waiting to be processed, so it's okay if one of those goes down. It's not okay if it's a front-end UI. That's got like a 10-second downtime maximum. That's all it's allowed. And we'll come back to that one in a second. So I use another tool called Rundeck. Rundeck is an orchestration tool that allows me to actually handle outages like this. Okay. So I have one Rundeck instance per region in AWS. And I go to my nodes page, I log in and I go to my nodes page and I can say, give me all the nodes. And it's not signed in. Awesome. There we go. Why is that not the case? There we go. So I go to nodes, and I can say, give me all the nodes that are in my system. Okay, and then I can say, I want the nodes that are tagged in AWS as Logstash. And it's actually doing a filter. And then I can take that node, and I can run a command on that node. Or I can run command across my entire infrastructure. It doesn't matter. But this can be anything. This can be tailing logs. It can be changing services, checking the state of the services. So I'm logged in as a specific user right now that has admin access to everything. By the way, this is behind a proxy. You can't get there in your face. Sudo service, logstash status. And it's actually going off to the box. It's making an SSH connection, and it'll tell me logstash is running on that box. We can do other trivial commands. Hostname. Tell me the host. Give me the date on the box. Sudo tail -f var log logstash logstash.r. Give me any logs that come out of logstash. There shouldn't be any. Let's kill that job and let's say give me all the actual logstash logs themselves as their forward messages. You can start to see all the messages going through our system. This has allowed me to take away production access for everyone. They don't need it. And every night I have a job that runs, and it actually goes to the system and says, hey, go through every box in our environment and tell me the boxes that are more than 2 weeks old. And it kills them. Because I don't want to be in the situation of long-run servers. Let's kill some. Let's go demo. So we generally have a convention of you have an autoscale group and you have an ELB name and a region and a timeout waiting for the box to come back up. By default, it's 10 minutes. It's never as much as 10 minutes. Let's start killing boxes. So let's just see if that one's come back. That'll come back in a few minutes. Demo. There's 2 boxes. There's currently a status check starting to fail because I've just terminated the box. There you go. 3rd box is spun up before it kills the last one because we do this in a high availability fashion. We don't want to go down to 1 box because if there's a problem then, we actually fail everything because we have no boxes serving traffic. So we bring a new one up. We take the old one out. And you can see exactly what it's doing right here. Because you'll see there's 2 instances in service. We need 3 before we terminate an instance. And it tells me the instances it wants to terminate. And every 10 seconds it checks back in that box and says, hey, are you in the load balancer yet? And if it's not, it goes, right, let's wait. And it'll wait, and it'll wait, and it'll wait, and so on and so forth. And we can leave that, and we'll go to Slack again. Don't install, it's fine. And you'll see notifications. Oh, look, the demo autoscale group has just launched an instance. Okay, this is easy stuff. Sorry? What about them? They're just apps. What happens to an app on one of your machines if it dies? You just launch a new system, right? It just deploys the app as part of the AMI. It'll still connect to all the different systems when they come up. It'll connect to React. It'll connect to MySQL. It'll connect to internal load balancers to talk to other pieces. It'll connect to service discovery. It's just an app. Obviously, if the app is stateful, then you'll want to have things that happen on SIGTERM in order to make sure it flushes through the system and doesn't lose messages. This specific one I chose was quite an easy one because I know it doesn't have state. And the app is like, it's not doing anything too big. It's actually just serving a UI that talks to APIs. But by putting these measurements in place, I can do whatever I want with the app. I can destroy as much of them as I want. This job happens every single night. Okay? Actually, it happens at 8 a.m. every morning. Okay? And by the time I get into the office at 10 a.m., it is usually cycled through all the boxes. And I could change the parameters. 14 days is just an arbitrary number. I could change it to 7, I could change it to 1. It doesn't matter. It's still exactly the same. We have base AMIs that are building stuff. Build. We have Packer builds that do all this for us. They build GPU images, they build base images. Okay? These are actually AMIs that are being launched into our system, and not only that, they're being tested using server spec to understand if the AMI is fit for purpose. You can take any of these tips. This is all open source. This is all open source stuff. I blogged about this 2 weeks ago, and it takes me to do security patches 20 minutes to build an AMI, run the test on the AMI, and actually deploy the AMI in place of another one. 20 minutes is really fast in order to deliver a security vulnerability. We'll check back in those boxes. Actually, let's do it now. That's great. Oh, is there currently one running? Yeah. You'll see it takes an average of 12 minutes somewhere. There you go. 12 minutes to do the entire auto-scaling group. So it takes about 6 minutes a box, let's say. And you can see it's up to 230 seconds. And you can wait we can wait if you want. Just take some of these tips. This is easy for me to say, right? Because I'm in a cloud environment. I can spin things up. I can destroy things very easily. Anyone actually still using base metal boxes? Little bit more difficult for you folks. Little bit more difficult. But you can still use these types of tools. Pixie Boot works perfectly for delivering new boxes. So you have 700 gigabytes of data on a single box? Let's kill an Elasticsearch box. Let's do it. ES dash. Oh. Just thinking about it. Just thinking about connecting. I use a lot of different plugins for a lot of different tools. Which is the actual, okay, shutdown. Sorry? Elasticsearch? Oh, the data on a single box? So if I actually refresh it, it'll think about actually waiting. It's trying to refresh. There you go. Cluster's gone yellow because the box is on. All those shards of that box are all unassigned right now. It's gone. The data's on there. I've just destroyed the box. It's still. If you have a good structure of how your systems are laid out, and you start to make changes to optimize how things are there, it's just a number. So how long would your box be in production right now? Is it patched? Probably. We should talk. We should definitely talk. So, as well as this, I run my security tests every night. Every night, my system checks that our boxes and our front-end websites are free from Freak, Poodle, Ghost, Heartbleed, Shellshock, the new one, Logjam, anything that's classed as a new major vulnerability that has SSL or anything like that. We write a test for it. I don't write the tests. I just put the tools in place to let the developers write the tests. I don't even know all the front ends that are in place or all the different URLs. And this moves us into data center as code. Okay? Everything I build, all of my infrastructure is using a tool called Terraform. Okay? Terraform allows you to start creating your code that looks like this, and that is actually relating to resources in AWS. Okay. We're doing a workshop about this for 2 days to show people how to build these types of systems and how to move in this sort of way. And you can start to do things like manage your DNS, manage your CNAMEs, manage your name servers. This is all part of what we do. I'm still a developer. I'm not a sysadmin. Those guys are specialists. Those people are specialists. They do some amazing things around networking and how to rack and stack things and how systems all come together. I'm just making that work between the system admins and the actual people in code who don't actually, it's not what their concern is. It's not what their love is. I love this. This is new challenges every single day. And we can start to draw our infrastructure. Who knows what their production infrastructure looks like? A couple of people. It's supposed to look like that. Well, it's a good representation of how things go through different areas. What about disaster recovery? It's all disaster recovery. It's all automated. It takes me 6 minutes to completely spin up our entire infrastructure in a new availability zone. Okay. That's all it takes. So if EU West 1 decide, if Ireland is destroyed tomorrow, God bless, that'll never happen, it will take me 6 minutes to move it to another piece of the system. Let's say 7, just to give me a minute's extra time. Hello? What about data? Well, we have shards. Shards are moved, shards have replicas. Replicas are kept in different areas. We have data that's kept in Kinesis. We have data that's kept in S3. We have data that's kept in Glacier. We never destroy data. No, you can use the internal network of AWS in order to move data pretty fast. Like you're talking many megabyte a second, many megabyte a second. And as long as things are chunked correctly and have the ability that they're able to be moved, it's not a problem. It's really not a problem. Simian Army does this as well. Somebody asked me earlier. Netflix's Simian Army is amazing. Okay, they have 3 tools. They have many tools in the Simian Army. My favorite 3 are Chaos Monkey, simulates a machine outage, just destroyed a machine, it's starting to come back up. Okay, Chaos Gorilla simulates an availability zone. So Amazon is split into regions. Regions have availability zones inside them, and you can simulate an availability zone going out. Usually you need 3 for HA, because you never want to go down to a single availability zone. And then you have the last one, Chaos Kong. Chaos Kong will allow you to simulate an entire region, not just an instance or an availability zone, but a region. And very recently, AWS US East 1 actually had a major outage, and Amazon suffered Netflix suffered no downtime. Because they have these tools, they practice, they can move their systems around really fast. They can fail over between data centers. They have data replicas in loads of places where they know that they can fail fast into. Just by putting all these little pieces of infrastructure, not these specific ones, but they have a lot of their own custom-built ones, they can start to move things around very easily. There's a continuous delivery maturity model, okay? Basically, you can go and have a look in this. This is on InfoQ. This is a really good article, actually, I have to say. That's why I include it. The further across to the right you are, the better, okay? You're never going to be perfect in this stuff, and I promise you'll never be perfect. But if you start doing 1, 2, 3 little things right and better, and more logging, and more metrics, and more communication, you'll start to move in that direction, I promise you. Puppet Labs, and this is my last slide, I promise you. Okay. They gave us the benefits of continuous delivery. Okay, they took a survey of people who actually implemented continuous delivery in DevOps, and they said that high-performing IT teams are more agile. Okay, I want to get you the numbers. Come on, there you go. Okay, so they can deliver code 30 times faster with 50% or thereabouts less failures. Okay, that's an awful lot of saved time. High-performing IT teams can recover faster. They can recover up to 12 times faster than they could before. Netflix, they don't even suffer anymore. They're so finely tuned. There are so many amazing cloud companies who are so finely tuned that they don't really have disaster recovery. HipChat, unfortunately, are not quite there yet. They suffer a lot of downtime, but they're moving in that direction because they're starting to take advantage of all of these types of practices and technologies. Okay? And the last one, high-performing IT teams can experiment more. If you spend less time with failures and you're delivering your code faster and using these little tools that you can allow development teams to self-service what they do and what they deploy and how they deploy and the types of systems they can deploy, you can spend less time firefighting. And you can spend much more time actually experimenting with your project and making your users happy. Continuous delivery means better projects for you and your customers. And I don't just mean external customers. Your internal customers are just as important. My internal customers are my developers. I want to build the best systems that I can for my developers. I'm out of time. Thank you all very much. Find me if you want to ask me questions.